Hello everyone. This is the 7th video in a series of videos going over how to program using the Arduino. In this video we're going to be going over logical errors. Remember that in the previous video we talked about syntax errors, where a syntax error is kind of akin to a grammatical error. When we have syntax errors in our code will not compile, and the code doesn't really make sense to the computer. Logical errors, on the other hand, are when we tell the code to do something and it's syntactically correct. The computer understands what it means. However, what we've told the computer to do is not what we want it to do. We're telling it to do something other than what we're trying to get it to do. And so for that reason, logical errors are a lot more difficult than syntax errors. When we get syntax errors, the code, when we try and compile it, is actually going to spit out certain error messages that tries to help us fix the errors. But when we have logical errors, we really don't get any message from the computer as to what's going on wrong. So we really have to dig into the logic of our code to try and understand why it's not working as we intend. So what we're going to do is, again, we're going to continue off of what we did last time. So first I'll be showing you just a picture of my setup. And just so you know, we're going to be assuming here that all of my LED lights are plugged into the pins that I've said. So the red LED pin really is plugged into pin 9. The green LED really is plugged into pin 5, and the blue LED is really plugged into pin 3. Those aren't any of our errors. And then from our work last time, we found that when we fix all of our syntax errors, as we have here, and when we run the code, absolutely nothing happens. We run the code and none of the lights turn on, there's no blinking, nothing is happening. So we're going to try and go through the code and figure out why this is. So first, take a minute and go ahead and copy the code as I have it here, if you haven't done it from the previous video. So pause the video and copy what we have up to here. And then copy the rest of this code here. I think I can get it all. So go ahead and copy all of this as well. And you can verify that this has no syntax errors by hitting the checkmark button up here. And you can also verify that when you upload it to the board, as I've done here, none of the lights turn on. Okay, now again I said that logical errors are really difficult as compared to syntax errors. And there's not going to be one set way to go about trying to find the logical errors in the code. A very good start is going to be to think about what you want the code to do, and then read the code line by line and make sure that it is doing exactly what you want it to do. Another method, which I'm going to do for this video, is just starting to think about different problems that might be occurring and testing to see whether or not that problem is occurring or if it's working the way we intend. So the first thing I want to look at is this delay time. So the delay time is initially 1098 milliseconds. And then we are writing, we're turning on these pins and turning them off, and we're having the delay time set in between them. And what I first want to check is I want to make sure that that delay time is not really small or not 0. If it's 0, it might appear to us that none of the lights turn on. So the way that I'm going to do that is I'm going to use the serial monitor. And again, we first, in our void setup, have this command serial.begin 9600, which allows us to use the serial monitor. And then what I'm going to do is within void loop, I'm just going to add the command serial.println. So it's going to print on a new line. And I want it to go ahead and print the delay time. So again, what we're trying to check here is we're trying to make sure that the delay time isn't 0. It's not so small that we're not actually seeing the lights turn on. So let's go ahead and upload this to the board. Okay, so to upload it to the board, we'll go ahead and open up the serial monitor. Okay, and we're seeing that our initial delay time is set at 1098 milliseconds, and that is what's being printed. And then all of a sudden it kind of jumps to 0. So at least initially, when we have the delay time set, it's at 1098 milliseconds. And so we should be seeing it turn on and then wait for that amount of time, turn off. So we should be seeing some blinking before it just kind of jumps to 0 and gets set there. So now I'm going to get rid of that print. Okay, so now that we know that the delay time, at least initially, is correct, let's now go ahead and look at these digital write statements. This is where we're turning the pins on and off. So for instance, looking at this first digital write statement on line 22, we're seeing that, okay, we're writing to the red LED pin, and we're turning it on high. And one thing that's good to check when we're using these built-in functions, especially when we're using these built-in functions with more than one input, we want to check and make sure that the order of the inputs is correct. So right now I'm trying to tell it, okay, turn the red LED pin, turn that pin to high. The problem though, if we remember the order of the inputs for the digital write, is that this is actually backwards. The first input on the digital write is actually the pin that we want it to write to. So first we have to write red LED pin, and then we have to tell it high. And we're going to have to do that for all of these. We're going to have to switch the order of these inputs. And it's really, really interesting that this didn't provide any syntax errors. You would kind of think, or at least I would think, that if the order of the inputs was switched, then these functions wouldn't work. It would give you a syntax error. But it actually turns out that in the computer language, when we write out high, the computer actually reads that as the number 1. When we write out low, the computer reads that as the number 0. So it actually thought that we were writing to pins 1 and to pin 0. And then whenever it sees a non-zero number, like red LED pin, which up here we see is 9, whenever it sees some non-zero number, it just takes that to mean true, which in the computer's language is the same as 1. So it thinks that we're trying to turn pin 1 on, and then it thinks that we're trying to turn pin 0 on also, and it's not really not doing what we want it to do. So let's go ahead and change all of these. We're going to switch the order. Okay, so we've got those orders switched, and now hopefully the lights will turn on and off. So we're going to go ahead and upload it to the board again. Okay, so doing this does cause the lights to blink. However, it only really blinked for one cycle, and then now all 3 of the lights are turned on simultaneously. So what's going on here? So remember how earlier we used that serial.println command, and we printed the delay time. And when we did that, we noticed that the delay time initially was 1098 milliseconds, which is what we had initially. But then it immediately got set to 0 right away. And so originally, at first it blinks with a delay time of 1098. And then all of a sudden it's blinking with a delay time of 0. And when it does that, all 3 of the lights just look on. For me, they're kind of dimly lit, but they all look on. And so now we have to look at, okay, where are we changing the delay time? What's going on with that? Why is it that the delay time all of a sudden jumps to 0? And so looking here, all right, we've got all of our digital writes and delays, so we're going to skip over that. And now we have this conditional statement. And what we're trying to check with this conditional statement is we're trying to say, as it says in the comment, if the delay time is ever equal to 0, we want to reset it to a random number between, say, 900 and 1000. And so we're checking if the delay time is 0, then do this. The problem is when we say if delay time equals 0 with just one equal sign, this is actually a definition. It's just like up here when we say, red LED pin equals 9. Down here when we say delay time equals 0, we're actually telling the Arduino the delay time is equal to 0. And when we set it equal to when we set delay time equal to 0, when we're saying is this statement true or is it false? Remember I said that with the Arduino's language, true just means a non-zero number and false is 0. So when it's saying, is this true? Well, it sees 0, and 0 is false. So it never gets to here, it never changes the delay time. And what happens is, it just sees that this is set to 0, it's false, and so now forever afterwards, the delay time just is 0. And so the way that we're going to fix this is, remember, in order to check if something is equal to something else, we need to use this double equal sign. So now we're going to go ahead, and I'm going to keep this serial.println command. We're going to keep the delay time, and we're going to double check and make sure that it's not just instantly getting set to 0. And we'll go ahead and upload this back to the board. Okay, so it's uploaded to the board. We'll go ahead and look at the serial monitor. We see, just like before, that the delay time is 1098 milliseconds. But now it's still 1098 milliseconds. And it's still 1098 milliseconds, and it's not changing. And remember, what we wanted was we wanted to have the delay time decrease. So we wanted it to be blinking faster and faster and faster until it reached 0, at which point it reverted back to some higher number. And so we want the delay time to decrease, but when we're looking at our code, we've got all these digital writes, so we're turning all the lights on and off. And then down here we're saying if the delay time is equal to 0, then reset it. But what we're forgetting to do, what we haven't done yet, is we haven't actually written any code that's going to decrease the delay time. So let's go ahead and say that, okay, now after all the lights have been blinked through one cycle, we're going to redefine the delay time. We're going to say that the delay time is equal to whatever the delay time used to be minus some random number, maybe up to 100. So again, what this is doing is saying, okay, initially the delay time is 1098. We're going to redefine it as 1098 minus some random number. And so it'll get shorter and shorter each time through. So now again, we'll go ahead and re-upload this to the board, and we're going to take a look at the serial monitor and see what the delay time is. All right. Again, just like before, it's starting at 1098. Okay, but now it's 1091, so it's gotten a little bit shorter. And so on. Now it's 1042. It's getting shorter and shorter. Okay, so good. This is good. This is getting closer to what we intended at the beginning of this whole project. So now the next thing that I want to point out is that, remember we said what we're trying to get is, we're trying to get the red light to turn on, and then simultaneously the red light will turn off and the green light will turn on. But unfortunately, the way that it's going right now is that the red light turns on and then it turns off. And then the green light turns on, then the green light turns off. Then the blue light turns on and the blue light turns off, and so on. So what we want is, we want these lights to turn on and off simultaneously. So now we need to look specifically at these statements here and see what's going on here. So remember, we want the red light to turn on first. So this is digital write, red LED pin, high. And then we want a delay. So far, so good. Then we want to simultaneously have the red LED pin turn off, which is what this is doing. And we also want the green LED pin to turn on at the same time. But unfortunately, right now, we have the red LED pin turning off, and then we have another delay. So what we need to do, actually, is get rid of this delay. So now, going back over this, we're turning the red light on, and then we're waiting a certain amount of time. And then we are simultaneously turning the red light off and the green light on. And then again, we're delaying. And now we want to simultaneously turn the green light off, which is what this line does, and turn the blue light on. But again, we have this kind of pesky delay in there. So we're going to go ahead and get rid of that delay. And then similarly, we've got the green light and the blue light turning off and on at the same time. And then we're waiting. And now we're turning the blue light off. And we're going to have to get rid of this delay as well. So now let's go ahead and re-upload this to the code, and let's double check and make sure that now when the lights turn on and off, they're doing so simultaneously. And just for fun, I'll also bring up the serial monitor. Okay, so now looking at the lights, we're seeing that the red light turns on, and right as it turns off, the green light turns on. And then right as the green light turns off, the blue light turns on, and so on. And it keeps going through this cycle. So far so good. It's looking like the program is doing exactly what we want it to. Now what we want to do is we want to double check and make sure that now once it gets down to 0, we want it to reset. So let's just wait a little bit and see what happens. Interesting. So the delay time has actually gotten into the negative number, so now we're at a delay of negative 13 milliseconds, which doesn't really make sense. And what's going on right now is that I'm looking at my breadboard, and the red light is turned on, and it's just stayed on. So what's going on here? What we said we wanted is that we said once the delay time gets down to 0, we want it to reset. So let's go ahead and look at that portion of the code. We're saying if the delay time equals 0, then reset it. But as we saw, the delay time never actually reached 0. It passed 0. It overshot 0. It went to, I think, negative 13. So I think what we want to say instead is not if the delay time ever equals 0, but say if it's ever, say, less than or equals to 0. Now, when it's ever less than or equals to 0, we're going to reset that delay time up to some number between 900 and 1,000 milliseconds. The really interesting thing is that we were able to tell the computer, oh, go ahead and delay for negative 13 milliseconds. But what does that even mean? What does it mean to delay for negative 13 milliseconds? Again, this is another case where you would think that the Arduino would give you an error. You would say, you can't delay for a negative amount of time. That doesn't make sense. But it turns out, apparently, that if you tell the Arduino to delay for some negative amount of time, it seems as if it just delays forever. It gets up here and it says the delay time is negative 13 milliseconds. And then it turns the red light on, and then it says delay for negative 13 milliseconds. And it just gets stuck here. It just gets stuck in this delay forever. And the red light just stays on. So it's another really interesting thing to watch out for, is that there might be times when you think you get a syntax error, but you don't. So you really got to be watching out for that. So let's go ahead one more time and upload the code to our Arduino. Okay, and we're going to bring up our serial monitor again, and we're going to make sure that once the delay time gets below, at or below 0 milliseconds, that the delay time shoots back up to somewhere around 1,000, and then the cycle just continues. And so far, everything is just looking, just like it did before, which is to be expected. The suspense is killing me. Okay, so perfect. So our delay time got down to 80 milliseconds, then 20, and then it surpassed that, and so it was reset to some number between 900 and 1,000. Okay, so this is going to keep going forever, just like this. It's going to continue in this blinking pattern that blinks faster and faster until the delay time gets at or below 0, and it's just going to reset, and it's going to do this forever. So we have finally been able to fix both all of our syntax errors and all of our logical errors. And I really want to hammer home that the logical errors really are the most difficult aspect of coding. When it comes to programming, the computer is always going to do exactly what you tell it to do. Computers are very stupid. They only do what you tell them to do. So whenever you tell them to do something, they're going to follow it blindly. And you might say, I want you to do this, but if you've told it to do something else, it's going to do whatever you tell it. So we really have to be careful and make sure that we tell it exactly what we want it to do. So this has been the 7th video in a series of videos going over how to program using the Arduino. I hope you found this video useful, and I look forward to seeing you in the next video.